Alright, so you've seen the completed projects, now let's begin the construction of it. So I'll take you back in time. Right now it's November 4th, 2021, so this is a long-term project that I'm going to be piddling around with between now and hopefully July of 2022. So I figured I'd get an early start on it so I can get all the bugs worked out to have it perfected by the time the final video is made. So, and if you can skip all this part if you just want to see the beginning part of the video. You're not going to hurt my feelings, but this is for everybody who wants to see the construction and behind the scenes of the final product. So I've never done nothing like this. This is inspired by Charger Miles 007, by a lot of his projects that he's done over the years, and I've done some other projects. One in particular was a piston valve engine. I have a video on that based on the engine that he designed and built, based off of an old airplane engine. So this is going to be, as you've seen, 3 5-horse Briggs hooked together. I haven't really come up with a name for it yet. You all know more about this project than me at this point, so so it's going to be 3 engines set up in a chain-driven layout. I'm using number 35 chain to start out with. Hopefully this is strong enough to withstand the engine. I really doubt that these sprockets are going to work, so I'm probably going to have to order another set of sprockets because the keyway slots are extremely thin on this, and there's no way to put the set screw in, so these probably are not going to work. Not to bore you all too much, but I got to cut some more metal down here. As you can see, I got them not quite set right. Then we're going to start tacking everything up, sanding everything down, and go from there. I'm going to show you as little as possible on camera on the construction of the frame. I want to concentrate on the engines. So we might just go ahead and skip making a video on this, and we'll look at it after everything's welded and before we put the wheels on and everything. Let's go from there. And this is these wheels are just like push motor wheels. They're 1/2-inch bearings to fit a 1/2-inch bolt. This just happens to be a piece of all thread I already had. I was thinking about welding a nut on there and just run this through there like that, but I don't think I'm going to do that. I did want to say something else. I said this was inspired by Charger Miles 007, and I really appreciate it if you check out his channel. He makes some crazy engines, comes up with some very interesting projects. Keep you entertained for hours if you start watching his videos. I've talked to him. He's a nice guy. He's given me some advice over the years too. So anytime I get a chance to do a shout out for somebody, I always do. And I also want to give him credit. He did a much better engine than what this is going to be, because he did it like crankshaft to crankshaft, direct driven with couplers in between. His H engine was chain driven, but I think it was a bigger chain than this, so he probably knows more than me, and this is probably the error part of the trial and error, but we'll see what happens. But anyway, that's why I wanted to add on here, but he did like crankshaft to crankshaft to make it more like an actual inline engine, where this one's going to be 3 separate crankshafts all connected with a chain, which may or may not work. If it don't, oh well, but I don't have access to a machine shop or machine equipment as he does. He can do a lot more than I can at this point, but I do want to get into milling and machining and turning metal on the lathe and stuff. Something I always had interest in, but for right now I'm just trying to do a little project just to have some fun and make a good video for you guys. So let's get started. Alright, just a quick little look before I start welding on this. I got a mark for the braces underneath. This will be the bottom that's up. We've got exactly 4.5 inches between the outside and here on both sides. I got this clamped in place just to keep this surface flat, so that this bottom is parallel, the top should be as well. Alright, so here it is after welding it. This piece is not welded to it, and that piece over here is not either, just sitting on that. Got decent welds. I used the titanium 225, so it's a DC stick welder, and so you get a little bit smoother weld for me anyway. The main reason I use the rod welder is just because this is a little thicker metal. It's probably about 3/16 thick, this channel is, and these plates are about 1/4 inch, so it's pretty thick metal. We didn't burn through anywhere, so I know it was getting a pretty good weld on all of them. Okay, so I got the axle welded on. It's a pretty simple weld there. Got the legs built for this side. You can see here. Just got to dress up some welds because there's going to be some angle iron coming up here for a handle and gas tank bracket and everything. We got pretty much marked off where the blocks are going to go. I just got to mark and drill all the mounting holes. Alright, so we got the bolts to mount the engines with. These are 3-inch. Just as luck has it, my bolt bend goes up to 2.5 inches, so I had to buy bolts even with all the bolts I had. So I went ahead and got a lock nuts for it. I think that'd be a good little additive to keep the engine from coming loose. So I already got the holes marked for the first one to drill. I'm pretty sure they're in the right spot. I'm going to have to verify. I'm using this, my engine stand, to mark the holes. I'm just putting a mark right in the corner of the farthest part. I'm going to center punch them before I drill them. We just got to make sure everything is going to be perpendicular, like right in line, so there's no change going at angles or anything. Alright, so my little drill press I did was a complete fail. It did give me the pilot holes, so that gave me alignment on everything. So I just did a test mount with this engine block here, and using 4 bolts in each block, and everything's lined up perfectly on here. So I ended up doing 1/4 inch, and then 5/16 with a hand drill, and got perfect alignment doing that. So we're good to go. So now we get you on time lapse of bolting the engines down. This is just going to be a temporary bolting because these may not be the engines that's used on this. It just happens to be the one that's close by, and we're just going to use that for testing purposes and building the manifolds and stuff. Alright guys, we got everything bolted down there. Bolts are just perfect length. Everything lined up good. Bolts went in, had a little bit of trouble on this one and this one. A couple holes were plugged up. After that, it wasn't no big deal. This ain't the original cover for this engine. This block is in a better shape than the one that this came off, than the engine that this cover came off of. So we're just gonna go with that for right now. So I'm gonna turn around and look at it from the other side just to kind of see what we're up against. The way I'm gonna do the manifolds, I'm gonna have the intake manifolds coming out here like this, and one pipe run through there, and the carburetor here in the middle somewhere is what I like to do. Might be offset a little bit either here or down here. Don't know yet. That way I can just put like a 4-way pipe fitting in there. Do it like that. So here it is from the PTO side. I've never seen an engine with this short of a crankshaft. I don't know if that was machined down or if it was just special ordered for a tiller or something, but everything appears to be right in line, so should be good to go on that. So on to the next step, start building exhaust and intake manifolds. Same thing with the exhaust. Each one of them is going to come out here, maybe at a 45, and go into one big long pipe, then some type of muffler setup. Alright, so at this point I'm going to start making exhaust flanges and exhaust and intake manifolds. I'm not going to go into an extreme amount of detail, but I did want to kind of hit and miss on how I'm going to do it before I got started. These are 3/4 inch washers, and you can kind of see what I got to do here. I got to drill out 2 1/4 inch holes and kind of shape it. It don't have to be exactly like that. Same for the exhaust, it'll have a similar shape to this. And for the manifolds, this is a 90-degree elbow, 3/4 inch EMT, which is electrical conduit. So what I'm going to do is cut this here, because I want the pipes to come out at like a 45-degree angle, at least on the exhaust. The way it'll kind of be pointing into the exhaust manifold. So it's going to be cut off here, then welded to these. Alright, so I just test fitting the exhaust flanges. Got the intake ones on this one. About the same on it, so we should be good to go. Just time to do some welding. Alright, so I got the 3 intake pipes cut. Just kind of used a square on this to kind of square it off with the piece that I cut off to get as close as I can to being square. So this is going to be stuck on here something like this. They're wanting to point up. I wasn't really planning on that. I wanted them perfectly straight and the exhaust perfectly straight, but just gonna have to do a little tweaking here and there to get it to level out. If it's up a little bit like that, it's alright. But okay, so at this point we got the end caps welded on, which I decided to use Welsh plugs from like a one-piece flow jet. Got the inlets tacked to the manifold, and I had problems getting these to seal with the flanges, so don't look at my welds. I'm pretty sure this is the carburetor we're going to use. This is a one-piece flow jet off of a 8 horsepower, not like the one that's on a 12. You see it's made just a little bit different. So I figure it should be good enough for running 3 engines off of. So I screwed up when making the intake manifold. I'm not going to show you a close-up because I don't want to get embarrassed too bad, but I got some pretty nasty welds on here. And my idea with welding this washer just crowds everything. It's not going to work. So I'm going to salvage the 3 intakes off of it and just cut them off as close as I can. This piece is going to be scrapped, and I'm going to use a 4-way cross instead of this, and we're going to use elbows on each end instead of trying to go on into the pipe like this. It'll give it a little bit better flow, and we're also going to be using the same size pipe all the way down instead of this big pipe. Alright, so it's December 1st, and pretty much got the intake manifold set up. Got much better welds with a new tip and a new helmet so I'd actually see what I was doing. Still not the best, but you know, it is a flux core welder. But you can kind of see what's going on here. Made it like this so I can make another one of these or drill other holes in this for different types of carburetors and configurations. The only thing I'm slightly concerned about is I got a little bit of a tilt on the carburetor somehow. I thought this piece was down more than it was, which I don't think it'll interfere with the performance of the carburetor any. Should work just fine. I had to make this bracket here just for a little bit of support like this. This is just sitting on here. May or may not be the type of filter I use, but it will work. And got a very temporary throttle spring set up. You know me, I didn't get it on camera, but I sprayed a little carburetor cleaner there and cranked over engine number 3, and it fired up and almost blew itself up because it was running so lean. And I figured, you know, there's no intake gaskets on there, so I'm probably getting a little bit of air in between there. So I did the same thing on number 2 just to see what it would do, and it did the same thing. I didn't want to over rev them too much, so I just did it one time. I just had to see it, you know, do something. So on to the exhaust manifolds. I'm also going to run some bracing in between here at the top just to keep from flexing and crushing the manifolds. And this carburetor is for an 8 horsepower vertical shaft, and it's a little bit big, and I was tempted to go with a smaller carburetor. So if we have issues with starting and not wanting to idle down because more increased airflow, then we'll change it out to something smaller. But for right now, it's what I decided to go with. I figure, you know, for an 8 horsepower engine's bigger displacement with 3 of these, it's equivalent to, might as well say, a 15. So it should be adequate. I'm not going to be running it wide open anyway. I don't want to take it over 4,000 and 4,500 RPMs at tops. So on to the next step. Alright, so a little bit of an update. Got the exhaust manifold done. I got a little bit better welds with this side than I did on the other side. You see, it looks kind of nasty on that one because I was trying to get it to seal. Had a couple of leaks on it. The exhaust one seemed like it sealed pretty good. So kind of explain how I did this. This is 3/4 inch EMT conduit, same as what I used for this. 3/4 inch black iron fittings. This is 1 inch thread on the T, and again this is all 3/4 inch on this side. And in order to adapt it to the 1 inch T fitting, I put a piece of 1 inch pipe in here and tightened it down with a pipe wrench, and then cut it off flush with that. Then took one of these, which is a coupler for the 3/4 inch conduit, took the screws out and grinded that down and pressed it in here about this far. That way it would fill in the gap from this, and everything just fit together like it was made to go together like that. Also, another reason I got a little bit better welds is I picked up a new welding helmet that the auto darting actually works on. So then for the middle engine, I drilled out the side, like right here, using a 1-inch hole saw, and just had to fill a gap in with the weld. So that's how I made my own custom T-fitting for this. And this is probably the muffler it's going to be used on it, which has 1-inch pipe thread, and this is a vintage Nelson muffler. This is a kind of a hard muffler to find. So now the next thing I got to do is make a brace that runs from each engine, in between each engine. I'm going to do that off camera, and we'll look at that and go from there. Alright, so I just made up a really simple brace to run in between the engines, anchored by head bolts. It's just something to kind of keep anything from flexing or pulling or anything like that, because I don't want the space between the engines to move, because it could, you know, potentially bend or crack a weld or something on the exhaust or intake manifolds. Alright, so we got a little bit of a chain setup going here. This is the stationary tensioner, and this is the adjustable tensioner. I almost went with the spring-loaded tensioner, which we may change it out at some point. But this way I can just loosen these nuts and tighten it up. The nut that's welded to this was drilled out 1/2 inch for this just to slide through it. Alright guys, so a little bit of an update. It's December 12th, 2021. I got the handle and the what I'm calling a control panel assembled. Got a tachometer, air meter, 3 switches for the ignition, and it just bolts on. Everything's bolted on this. Got a piece of threaded rod running all the way through there. I thought about some type of bracing, but I don't think it's going to be necessary to try and keep things simple. Down here we got a Tecumseh gas tank, I'm pretty sure, anchored to 2 head bolts. And then it's got a brace that runs all the way down here to the frame, and again everything's bolted so it can be taken apart easily. The gas tank's pretty stout. It was kind of wobbly without this brace. Next thing I got to do is take the intake and exhaust manifolds off, pull the heads off, flywheel covers, and get ready to start timing everything. It's pretty much ready except for a little bit of wiring and the timing process. Alright, so it's been about a week or so since I worked on it. It's now December 21st, and I'm going to get ready to start taking things apart so I can set the timing on everything. And I'm just going to kind of hit and miss on it and maybe show things while it's all apart with the parts laying or something. I'm going to go ahead and prime the intake manifold. That way if there's any real small air leaks anywhere, the primer will seal it. And I just thought that might be the best thing to do for that. I'm going to let the exhaust manifold get good and hot before I prime it. That way it'll burn off any residue or galvanized coating or anything that I might have missed. At some point during the testing of the engine, we may not run the exhaust manifold and just run individual mufflers just for testing purposes. To see if, especially if we got any smoke, we can tell which engine's smoking. Which if any of them's going to do it, it's probably going to be number 3. Because I don't know too much about that. I know these two are, at least they were in good shape the last time they were running, no smoke at all. But that way we can, you know, diagnose the engines a little bit more and go from there. Alright, so at this point we got all 3 engines stripped down to pretty much nothing. Get the chain off, just sitting there. I just wanted to share with you the condition of these engines. This one I knew for a fact was almost in mint condition because it didn't smoke at all, and it's still got hone marks in the cylinder, so it's a low hours engine or was rebuilt at some point in its life. This one I see a few light hone marks. And if I remember, it didn't smoke any either. And this one, conditions unknown. And I don't see no home marks. If we're going to have any problems out of one using oil or something, it's going to be this one. Start setting the timing, getting the timing laid out on each flywheel and everything. So the way you figure out multi-cylinder engine timing, you take the number 720, which are 720 degrees in 2 revolutions of a crankshaft on an engine, because one rotation is 360, so 360 times 2 is 720. So that's how many this flywheel has to turn over twice in order for a whole cycle of the engine to complete. So you hear the term like a 4-cycle engine. It takes 2 revolutions to complete the cycle. So in order for the timing to be right on a multi-cylinder engine, you divide the number 720 by how many cylinders they got. So 720 divided by 3 comes out to 240. So that means each cylinder is going to fire 240 degrees apart from each other. So within the full cycle of one engine, all 3 engines would have made their complete cycle as well. It's just the way the timing works on any multi-cylinder engine, even a V8 or anything. It just all divides. So the first step is to find top dead center on all 3 engines, and we're just doing it by eye, because I'm not going to go into like getting this down to the exact degree and everything, because I'm probably not going to be able to do it anyway, because it might be offset on a tooth on one of the sprockets too, so you got to take that into consideration. And plus the chain will stretch at some point, so it's going to throw it off just a little bit. But as long as it's really close, it's really not going to matter, especially in a situation like this. It's not going to affect performance or anything, because we're not trying to get all the horsepower out of this as we can. If it's extremely out of timing, or if one engine is, you can actually hear it and it'll sound almost like a misfire or like a blank spot. Kind of think of it like, if you had it like one cylinder completely out of time, it would almost sound like a 4-cylinder engine running on 3 cylinders. There'd be like a blank spot there. So top dead center is the piston all the way up on compression, and the way we're setting this is the second fin on the aluminum part of the fins points right at the bolt on the coil, and that's top dead center because it don't move up or down right there. So we got it set on all 3 of them the same. Now, the only possible thing that I probably should have checked is the flywheel keys on these engines. If one of them is sheared, it's going to throw my timing off, but it appears that they're all 3 the same. So right now, all 3 cylinders are on top dead center on compression stroke. So now I got to measure out the degrees on each one, so I can set the timing, and we'll have to spin it around and get the chain going on it. Alright, so I got the timing laid out. I got the top dead center marked on all 3 of them, but on cylinder 1, I have 2 other marks. I was going to label them 1 and 2, but they're be confusing. There's the second mark, and back on top dead center. All 3 of these are spaced out exactly the same. I did that by wrapping a wire around the part where the fins are. You see there's silver marks. It's 21 inches around, so divide that by 3 to get my 3 degree marks. So they're 120 degrees apart. You'll see why I need 3 marks here in just a second. And so that's how I came up with that. So kind of give you an idea of how this is going to work. So right now we're on compression on cylinder 1. So this is cylinder 1, 2, 3. That's going to be the firing order, 1, 2, 3. It's going to make it complicated putting the chain on, but I'll have to deal with it. So right now, cylinder 1 will be firing. You'll see all these move together here in a little bit, but right now I'm just kind of give you an idea of what's happening here. So cylinder 1 fires, passes the first timing mark, comes up on the second timing mark. So at this point, cylinder 2 will be on top dead center on compression, so it'll be firing right now. Then we pass the mark on this. This engine's doing a dummy fire right now because it's getting it in between strokes. So on the second mark right here, cylinder 3 will fire on top dead center. then it'll skip a mark, and it'll be right back on top dead center on compression on number 1. So that's how the timing is going to work on this. Now I just got to put the chain on and make it happen. It's extremely hard to work on something like this. In order to set the timing, I really need access to both sides just to keep things simple. So I ended up using my trusty old welding table here to help me out. Alright, so I got the timing set as close as it's going to be. You know, like I said, you know, you got to figure in the distance between the tooths. So if you skip a tooth, you know, how many degrees is that, you know, one way or the other. So you got to take that into consideration. So right now, cylinder 1 is firing. I'm going to line up the mark where cylinder 2 should be exactly. And we're offset, you know, about a 1/4 inch, close to a 1/2 inch away from it. Took it 1 tooth back, and this line was all the way back here. So I'm just going to leave that alone. So now this will be cylinder 3. And it's going to fire just a hair early. And again, I tried to adjust it, and it went way too far one way or the other. So this one's actually very close. This one's just a hair late, so I think it'll be alright. So now let's do a crank over with the drill, just to real slow and real fast, just to kind of show you what's going on. Hope this angle is going to show you everything. Kind of concerned about you being able to see number 3 piston. So let me get it back on cylinder 1 firing. Fire, 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 fire. So just 1, 2, 3 firing patterns. And again, just to give another angle. Fire, fire, fire. Alright guys, so it's Christmas Eve, 2021. I'm getting ready to do a little bit of extra time, so I thought I'd go ahead and get the heads put back on it. I was planning on cleaning the carbon off the best I could, but I think we're just going to go with it. Throw them back on, because I'll probably be taking it back apart eventually anyway. Alright, so I got the wiring done. This might just be a temporary setup, or we might keep it, not sure. Anyway, I just got one wire coming off of each coil, going back to each switch, and then going to the ground right there. And I already tested it, it works. That's what the plugs are out for. So cylinder 1, 2, and 3. That way I can turn just 1 or 2 off to test to see how one's running, or to see if one engine will run off, or just for anything I need to do. And if I need to shut all 3 off at the same time, I can do it just like that. Or if I determine to get a smoother shutdown, shut off all of them individually like that, you know, we might end up doing that. So we'll just have to experiment with that. So next thing I want to do is put the flywheel covers back on off camera, and put the exhaust and intake manifold on off camera as well. Alright, so we get the wiring done, get the flywheel covers back on, the intake manifold on, the carburetor done, fuel line routed, got a fuel shut-off valve, inline filter. And I like the clear one so that way we can make sure we're getting flow, because we don't have the best elevation on the tank, but it should be enough to get some decent amount of flow as long as the tank's at least 3/4 full. It's all 1/4 inch fuel line, zip tied. Might make some other type of bracket or something. I'm also concerned I don't have no way to set the choke on this if we need to set the choke. We'll probably prime it with some carburetor cleaner. Gotta put a spring on the throttle and do the exhaust. I might just do individual mufflers for right now, just for testing. I can't really decide. So now the next biggest step is getting it off the workbench and onto the floor. Not sure what this weighs, but it's not light. Alright guys, I'm getting kind of scared, about ready for a test start. I'm going to have safety glasses on just in case the chain decides to fly apart. I'm going to stand off to the side. For exhaust gaskets, at least for a temporary setup, I end up using Permatex Ultra Copper, and never used it before, but I didn't want to waste money on the exhaust gaskets and take a chance of ruining them, which I probably will order them for the permanent setup of this after everything's painted. But so now I just got to check the oil on all 3 engines, because each one does still have its own crankcase. It's not just like one crankcase for this. And put gas in it, but before we put gas in it, we're going to spray some carburetor cleaner at it and do a little test fire just to see what happens. Get the 3 switches on. So I just want to note that I did have each individual one run just to make sure, you know, that everything was still working, that all 3 engines were in running condition. I still think we're going to have problems out at the 3rd one. I just have a feeling, but hopefully not. It came off instantly. So here's the new setup. Don't know if it's going to work, but we're going to find out. So we got a longer tensioner on here. Let's move the stationary tensioner over here, and I'm just going to hope for the best. It'll probably pop off a break, but we'll find out. I'm going to the trial and error method, just trying to adjust everything till we eventually get it. We're just going to run the single mufflers right now, so I don't have to keep taking the exhaust manifold off. Alright, so I thought I'd share this with you. This is how much the threaded rod bent. This was the part that was mounted in the frame. That's how much it bent as soon as the engine fired one time. One of the cylinders fired. So this is just standard steel. You know, it's non-treated, not hardened, just like a piece of steel. It's about the weakest bolt type you can get. It's probably weaker than a grade 2 bolt. So I just got this. This is a grade 8, 1/2 inch, 6 inch long tap bolt. Try to find that local. Just look around and see. Not very common. Had to special order it. So I ordered 2 of them in case I messed one up. So if this bends or breaks, then we're going to take the whole thing completely apart and redesign the tensioner mount for the stationary sprocket. So I'm just getting the new chain tensioner set up, and I thought I'd show you how I'm setting the timing on this without taking the flywheel covers and the intake manifold off. Because in order to take these covers off, the intake manifold had to come off, except for the last engine. So I took the little shield off that would go around here on each cylinder. That way I can look in and see the coil where my timing mark is. Then take the spark plug out so I can watch the valves and the piston. Make sure I got it on the right stroke. Sorry about the congestion. I got like a sinus infection at the moment. From sanding and stuff at work. But so I came up with a new design. Everything wants to keep bending and everything, so we're going to go with what I should have done in the first place. 2 chains, 4 sprockets. We're going to have a double sprocket on the center crankshaft, going to a single one here, and I got to order another one for this one. I still got this tensioner set up here, the idler sprocket. So there's going to be 2 separate chains like this between each one. I think this will be a simpler way to time it first of all, and only disadvantage will have to be 2 tensioners. I got the first chain made and set up. I just put it together, not really paying attention to anything. These motors are actually timed to run as a twin cylinder, so it'd be 1, 2, 1, 2, 1, 2, just back and forth. I believe it's called even fire instead of odd fire. After we get a tensioner made on this, we might try to go for a quick little 2-cylinder run, just to kind of see what will happen, kind of test the tensioner idea. Because if it works on this, it should work when we add number 3 to it. Actually, cylinder 1. But kind of make it a little more interesting, kind of make a little like a stepping stone, I guess you could say. But this is how much play I got in between. Alright guys, so it's January 8th, and got snowed in a little bit, and it's time to work on this again. We got about 8 inches of snow right now. So this is pretty much ready to go. The test run is a twin cylinder. The other sprocket did come in for cylinder 1. We're just going to go ahead and test this before I build another tensioner assembly like this, because this one fails and I've just been wasting time on that one. So we'll just test it as a twin cylinder first, and I'm kind of anxious to see what it sounds like. It's going to fire 1, 2, 1, 2. It's an even fire, so both pistons are coming up at the same time like this, but each one is on a different cycle. So I'm going to do things a little different this time. I'm going to put gas in the tank, and we're actually going to try to run it off of gas instead of constantly spraying carburetor cleaner in it. And we're putting the camera on this side, that way if we have another problem with the tensioner, we can see what the problem is. Alright, so I think the chain drive is going to work. It seems to be working just fine except for a little bit of noise. But now the next problem is cylinder 2, the white engine, is not wanting to run at the same time as this one all the time. Like if I throttle it up and choke it, then you can hear it come in. But this is the primary one you're hearing running, and it's also a smoker, as I noticed. Never really had that engine running that much, but I know these two aren't, so I may have to pull that one off and rebuild it or put another one on it. But we're just at the testing point right now. So I'm going to do a compression test on 2 and 3. I'm going to do it off camera and I'll tell you the numbers, but we'll kind of go from there, because the only other possible problem could be like a vacuum leak on one of the tubes. You know, with any engine you want fairly balanced cylinders, and I didn't really think about it at the time, but I should have did a compression test on all 3 of them before I even bolted them on, just to see if they were kind of on the same level, so to speak. So, alright, so kind of interesting compression results. Went and tested all 3 to see we had the number. Cylinder 3, which I suspected as being the weak engine, is actually the strongest one because it's got almost 80 psi. Cylinder 2 got about 40. This one's got about 75. So this is the problem. I gotta figure out what's going on with this one. Probably just have to do a quick valve job on it. Alright, I tried a new head gasket. It might have picked up a couple more pounds of pressure, but here's the problem. The intake valve is not seating. See, I can't spin the exhaust valve. So I'm going to try to do a quick valve job. I don't know how much I can do without taking the engine off the assembly, so we'll get back at you. Alright, so I ended up doing a complete valve job on it. I say complete, but reseated both valves and set the valve clearance on it. Now we got probably about 65 psi, I would say. And this one's pushing 80, so I don't know why that one's got so much compression and smokes, but this is a lot more than twice the compression that it had. So. Alright, so after a semi-successful run, chain loosened up just a little bit, and I probably might snug it just a little bit to keep it from bouncing so much, but it seemed like the drive mechanism went really smooth, but this one sprocket keeps coming loose for some reason. You can see where it's been wearing already, so I'll have to try some different type of set screw or something on it. This one's locked in, so it can't come off. Might have to come up with some spacers or something on here. This engine's wanting to smoke a little bit, so like I said, the only engine that has good oil in it is the red one, so I figured while I'm getting ready to start working on the tensioner, go ahead and change the oil in both of these. So, alright, so now we get the second chain set up on there and tightened down. I had to readjust this one a little bit, put lock nuts on the top on both of these. It's a regular nut with a lock washer on the bottom. Everything's timed, ready to roll. I just got to put oil on these back 2 engines and put the mufflers back on once I get it on the floor. Alright guys, I think we're ready. Just put oil in both these cylinders, put the plates back on it. The timing's set, the spark plug's put back in, muffler's set up. So here's the new tensioner. It's basically just a replica of this. It's a slightly different idler pulley. I had to use washers in between. This one had a spacer. Other than that, it's identical. This sprocket was loose too, the inside one, not this one. So I went ahead and put double set screws on both of these, on all three of them. When it's running real fast, it's a little over 2,000 RPM. It sounds, like it's really running real fast because it's, the RPM times 3 or 1. So, well, I won't call it a successful run. What do you guys think? I do have a couple problems. It's only wanting to run the best with about half choke, which I kind of suspected that might be a problem. That could be too big of a carburetor causing that problem. So we might go with a smaller carburetor or come up with a little bit better setup on that. But it just seems like I can't get it to tune in unless it's partially choked. So once I get an air filter on it, that might solve that problem too. I don't know, we'll have to play with that. The only other problem, I keep losing set screws out of these sprockets, on the drive sprockets on these engines. And I heard a couple pings while it was running, seen something move, and sure enough, it was some of these coming out. So the short ones were the first ones that go in, and the big ones I'll put in to lock them down. So when the final assembly, it's going to be put together with red Loctite. So that'll solve that problem. And other than that, I'm not really having no issues, except for, like I said, that engine number 3 smoking. But, alright, so now on to the next part, taking it apart. After all this work I put into it, now it's at the time where I got to take it apart and paint everything. But I'm ahead of schedule by a lot. Today's January 9th was the first successful run. I got until July 4th to perfect everything. So I want to run it with the exhaust manifold to get it burned in, so there will be a running of it with that manifold. So I just put the exhaust manifold on there with the Nelson muffler. Oh, it sounded amazing, and all of a sudden the chain fell off on cylinder 3. It didn't just fall off, it broke right at the master link. Okay, so just a little quick update I thought you might be interested to know. Cylinder 3 decided to shear a flywheel key, and apparently it fired way too soon, and that's what caused the chain to break. But right now it's torn top dead center. You can barely see the piston there, and the top dead center mark's way over here, and it's supposed to be right here, so that's how much it slipped on there. So I'm going to pull this apart, put a new flywheel key in it, and lap the flywheel to the crankshaft. Alright guys, so it's January 10th, we got everything back together. Chain tension set on everything. Got the blue Loctite. I know I said red Loctite a while ago, but I went ahead and put blue on it. Alright guys, I'm going to call it a successful run. The sprocket came loose again, so apparently the Loctite did not work. So I'm going to have to come up with a little bit of a better idea on that. But yeah, we'll just have to go from there. I'm going to have to rebuild this engine and put another one on it. to stop that smoking. These two engines are doing pretty good. Probably won't show nothing more on this until we get ready to take it apart and paint it. So, alright, February 8th, 2022. I got the number 3 engine off and trying to figure out what's going on here. I think this is the main problem we got. It's causing too much slop and wearing this key slot out. And the keeps shearing the flywheel key, so, and it's burning oil, so I'm either going to rebuild this one or put another one on it. Alright, so I'm not going to bore you with a rebuild in the middle of this video, obviously, but I just want to make a couple of notes just for reference and everything. Just clean the block up real good. The piston and rod's in really good shape. There's no play on the rod. Cam looks good. Crank looks good. I think it was just the keyway itself was causing a problem on that. So hopefully we can use this crank. Everything looks good on it. It does have an excessive ring gap, so definitely needs a set of rings in it. I'm not going to hunt the cylinder because it's aluminum bore and it's not in bad enough shape to need to be bored out. So do a valve job with new valve guides, new rings and everything, and do it off camera, and might put a little clip of it running by itself just so we know if it's going to smoke or not. Alright, let's go for it. Got all 3 switches on. Alright, so the chain broke on this one off camera after I revved it up a little bit. That engine kept running on its own. Then it finally started speeding up. I had to shut it off. So there's nothing major wrong other than the master link broke. Alright, so here it is all apart. Got the 3 engines here. I ended up taking the gas tank off because the bracket would be longer than the blocks. So it'd be sitting at an angle and I was afraid something would get bent or broke. So I'll just paint it separately. It's not that big a deal. Probably paint the gas cap silver. I took the tensioners off. I moved them up to the top hole because instead of pulling down on the chain, I think I'm going to have it pushing up on the chain. It's going to do the exact same thing, but I ran out of adjustment on the bolt, so I think that should help a lot. And painted this. So middle part with the switches and the tachometer / hour meter mounts. Alright, so we got the exhaust and intake manifolds painted up. Okay guys, I did a little bit of stuff off camera here, as you can tell. I'll put some pictures in of the painting process. Not too much detail on that, but just kind of wanted to show you what everything looks like before I start putting it back together. This engine is the other color red that I was planning on using originally. You can see it's like a slightly oranger color, just not as red looking, so I went with this color. This is the only one that's not done with engine paint. This is done with acrylic enamel. So I'm sure we'll get some discoloration on the head and around the exhaust area right there at the fins, but it is what it is. I just really like the color, and most of the engine will stay the same. Put the white one in the blue one, our engine paint, so it should hold up good. Gas tank's painted, ready to go back on. And I started on this project in November of 21, so now it's April 17th of 22, so this project's being drug out quite a bit. But I'm just trying to take my time with it, not rush it, and hopefully won't run into no issues of it and have it ready to go for the 4th. Alright, so we've got all 3 of them bolted down. You can see a grade 8 or grade 5 bolts. Got the support brackets in. I was afraid, chew up some of the paint, but I can always touch it up later if I feel it's necessary. And here it is from the other side before I start putting everything on. All of the sprockets have been drilled for the set screws. The way it's got a keyway, a key, and a set screw holding it, so hopefully they don't come loose this time. Everything's been Loctited together too. Alright guys, so like I said, I skipped a few things on here. Got it all back together except for the chain. We'll look at the other side here in just a second. Just kind of want to do a walkthrough on it real quick. Had to put a new fuel filter on it. The other one completely fell apart for some reason. Got the wiring done. So you got everything tucked away the best I could. Put the sensor wire on the middle engine, since it's pretty much the main one, since it's got the double sprocket. So the only thing left to do on this side is put the sticker on here and here. And you can kind of see why I wasn't too concerned about the decals on the engines, because they're pretty much blocked anyway, but just kind of want to keep them original. I put a double gasket on the intake on the blue one, just because it acted like it was getting too much air in it for some reason. The air filter, which now has a filter in it. The only bolt I had that was like a factory style Briggs bolt was too long, so I had to put a spacer in here, which is just a race from a bearing. Seemed to work perfect. I epoxied the bearing to the bottom part of the housing, so hopefully that'll hold. As you can see, it's complete except for the chain. Went ahead and loosened the tensioner, that way it's ready to go. I think the motors turned out really good. They look good. Alright guys, so it's April 19th and the chain came in, so I went ahead and threw it together real quick. We'll get the tensioner pushing up on the chain instead of pulling down. Main reason I ran out of adjustment on both of them actually, and I thought this might be a little bit better setup, and I got a little bit more of adjustment on it, so hopefully it won't stretch too much. So these two chains are both number 35 chains, but this is the chain we just put on it. It's a 35H, which is a heavy duty. And if you look, the side pieces are considerably thicker. And one last detail I forgot to mention, I put easy spin stickers on each one. You can see. I originally planned on keeping that one, the blue one, but it looked a little rough, and I ordered 2 for the red and the white one, and the seller on eBay was nice enough to throw in a 3rd one, so I figured why not just put all 3 of them on. Alright guys, we're going to get ready to do the first start of it. Not going to be a real long run, just trying to get it running and get the carburetor tuned a little bit. And so I'll do a quick little walk around before I try to start it. I'll call it a successful run. Chain's loosened up a little bit, not as much as I was expecting. Still getting just a little bit of smoke from it, but it appears to be more black smoke where it's running just a little bit rich, and it has to run with the choke on just a little bit because I still think it's too big of a carburetor. Well guys, that's all I'm going to show on this video. I think this kind of sums up the construction of it and the painting and the final run of it. So now, on to the next big project. Got several things in mind. I'm not going to say anything yet because I don't want to get anybody's hopes up for anything. But the chain driven 3 cylinders is a success. So I like to eventually get to be able to machine it, the crankshafts and everything, so I don't have to have chain driven on something like this. But this is just kind of a novelty project and my first time working with multiple cylinder engine built from single cylinder engines, so kind of a learning process, and a very fun and interesting project. Took a long time. Like today's April 26th, the first run since it's been painted and everything. You can really smell that hot paint coming off them engines. I don't see no discoloration on the red one, and this paint's only rated for 200 degrees, so I'm sure after a real long run it'll heat up some. But well guys, if you haven't seen the other video, which will feature the pictures of it inside and outside, I haven't made them yet, but it's going to be up before this video, so you've probably already seen that. I put it up on the July 4th, the day I plan on putting it up. This will follow, and back to normal content for the channel. So, well guys, thanks for watching, and if you got any ideas for future projects, feel free to leave them below, and I'll consider anything. So, thanks for watching guys, it's been a real fun project. Catch you on the next one.